Looking at the map right now, we're dealing with something that goes beyond just a single winter storm. What we're seeing is a large-scale atmospheric pattern shift, and it's setting up a complex weather situation across a wide area of the United States. This isn't your typical weekend snow event. This is a dynamic energy exchange between two very different air masses, and that exchange is creating some serious weather potential. So let's break down exactly what's happening and what you need to understand about this setup. First, the big picture. The atmosphere right now is configured in a way that brings together multiple forcing mechanisms all at once. We've got a strong Arctic air mass pushing south from Canada. At the same time, we have moisture being transported northward from the Gulf region. And where these two air masses meet, we're seeing a sharp temperature boundary form. Along that boundary, an active low-pressure system is developing and moving. This isn't just a routine winter episode. This is a dynamic phase where energy is being actively redistributed across the atmosphere, and that creates the potential for significant impacts. Let's start with the Arctic air block, because this is the foundation of everything else we're going to talk about. Across the northern and interior portions of the country, deep cold air has settled in and locked into place. Temperatures are running well below normal. Surface freezing has intensified, and this cold air isn't just sitting there passively, it's actively pushing southward, trying to expand its reach. This Arctic block is important for a couple of reasons. First, it's a sign of a longer-term pattern change. This isn't a quick hit of cold that moves through in 24 hours. This is cold air that's going to stick around for several days. And second, it's creating what we call a cold base. That cold base is going to determine what kind of precipitation we see. When moisture moves in over cold air like this, it falls as snow. The deeper and more entrenched that cold air is, the more likely it is that precipitation stays frozen all the way to the surface. Now, overlaid on top of that cold air base, we have an active low-pressure system. This system has developed along the temperature boundary between the cold air to the north and the warmer air to the south. And it's not a weak system, it's showing a well-defined spiral circulation. It has a strong frontal extension, and it's pulling moisture into the region. What this system does is create different types of weather depending on which sector you're in. On the northern side of the system, where the cold air is dominant, we're seeing snow. On the southern side, where temperatures are above freezing, we're seeing rain. And in between, in that transition zone, things get complicated. That's where we can see snow transition to sleet, then to freezing rain, and then potentially to plain rain, all depending on exactly where that temperature boundary sets up. And here's the thing about that transition zone. It's not static. It moves. It shifts. And small changes in the position of that boundary can mean the difference between 6 inches of snow and just cold rain. That brings us to temperature gradient, which is absolutely the deciding factor in this setup. The temperature contrast across the region right now is sharp. We're talking about deep, sub-freezing temperatures in the north and mild conditions in the south, all compressed into a relatively short distance. That sharp gradient creates what we call the snow line. And the snow line in a setup like this is not fixed. It's variable. A small shift in the track of the low-pressure system can move that line 50 or 100 miles in either direction. And when that line moves, the impacts change dramatically. A city that was forecast to get 8 inches of snow might end up with a mix and only 2 or 3 inches. Or a city that was expecting mostly rain might end up buried under heavy snow if the system tracks a little differently. This is why when you see forecasts for events like this, you'll often see ranges and uncertainty. It's not that meteorologists don't know what they're doing, it's that the atmosphere is sitting in a configuration where small changes have big consequences. Now let's talk about the precipitation structure, because this is where things get really interesting. What we're seeing on the radar is not just broad general snowfall. We're seeing banding, narrow, intense bands of heavy precipitation. These bands form along the frontal boundary and in areas where the atmosphere is especially unstable. And when you're in one of these bands, snowfall rates can be extremely high. We're talking about 1 to 2 inches per hour, sometimes even more. The problem with banding is that it's localized. If you're under the band, you get hammered. If you're just 10 or 20 miles outside the band, you might see much lighter snowfall. So the distribution of snow in this event is not going to be uniform. Some areas are going to overperform. They're going to see totals that exceed what the broad forecast suggested. Other areas might underperform. And that creates a situation where neighbors just a few miles apart can have very different experiences with the same storm. Wind is another major piece of this story. Around the low pressure center, we've got strong circulation. On the northern side of the system, where the cold air is in place, we're seeing a harsh Arctic flow. Winds are coming straight out of the north or northwest, and they're pulling that cold air southward. Those winds aren't just cold, they're strong. And when you combine falling snow with strong winds, you get blowing and drifting snow. Visibility drops, roads become treacherous, and the wind chill factor makes it feel even colder than the actual temperature. If you're in an area where snow is falling and winds are gusting to 30 or 40 miles per hour, it's going to feel brutal. On the southern side of the system, winds are out of the south or southeast, and they're transporting moisture northward, so the wind field is actually helping to fuel the system, pulling in more moisture and sustaining the precipitation. Here's the critical part, and this is something I really want to emphasize. The track of this system matters more than almost anything else. This low-pressure system is moving eastward, and it's going to continue moving over the next 12 to 24 hours. But the exact trajectory is critical. If the system shifts north, even by 50 or 100 miles, the snow area contracts. More areas see a mix or rain instead of all snow. If the system shifts south, the snow area expands. More areas that were expecting a mix end up with all snow and totals go up. This is what we call track risk, and it's one of the hardest things to pin down in a forecast. The models are good, but they're not perfect. And in a setup like this, where the temperature gradient is so tight, a small error in the track translates to a big error in the impacts. So if you're following this system, don't get too locked into one specific outcome. Stay flexible. Watch for updates. And understand that the forecast might shift as we get better data on exactly where this system is going. Let's talk about the longer-term pattern, because this system isn't happening in isolation. When we look at the broader atmospheric setup, what we're seeing is that this active pattern is going to persist. This is not a one-and-done event. The Arctic air that's in place right now is not retreating quickly. It's going to linger. And behind this system, there's potential for additional systems to develop and move through. That means snow accumulation could continue to build over multiple events. The ground is going to freeze deeply, and each subsequent system is going to have an easier time producing impacts because the cold base is already established. If you're in an area that's prone to winter weather, this is the kind of pattern where you need to think in terms of the next week or two, not just the next 24 hours. Now, let's get regional and talk about what this means for different parts of the country. If you're in the northern tier states, the Great Lakes region, or the interior northeast, you're in the heart of the cold air. Any precipitation that falls in your area is going to be snow. Period. The question isn't whether you'll see snow. The question is how much, and that's going to depend on whether you end up under one of those heavy banding features we talked about. If you do, totals could be significant. If you don't, they might be more moderate. But either way, you're dealing with snow and you're dealing with cold. Prepare accordingly. If you're in the transition zone, places like the Ohio Valley, the Central Appalachians, the Mid-Atlantic, this is where things get tricky. You're right on that temperature boundary. You could see all snow, you could see a mix, you could see freezing rain. It all depends on the exact track of the system and where that temperature line sets up. This is the zone where forecast uncertainty is highest, and it's also the zone where impacts can be the most dangerous. Freezing rain and sleet create incredibly hazardous conditions. Roads ice over quickly. Power lines can get coated with ice. If you're in this zone, you need to stay very close to the forecast and be ready for conditions to change. If you're further south, in areas where temperatures are going to stay above freezing, you're looking at rain, but don't think that means you're off the hook. Some of the rain could be heavy. There could be embedded thunderstorms along the frontal boundary. And once the front passes, you're going to feel the cold air rush in behind it. So even if you don't see snow, you're still going to feel the effects of this pattern change. One more thing I want to touch on is wind chill and how cold it's actually going to feel. When you have strong winds and low temperatures at the same time, the wind chill can drop well below the actual air temperature. We're talking about wind chills that could reach 0 or below 0 in some areas. That's dangerous. Frostbite can occur in minutes under those conditions. If you have to be outside, you need to dress in layers, cover all exposed skin, and limit your time outdoors. This is serious cold, and it deserves to be taken seriously. So what are the main risk scenarios we're looking at? First, deep snow combined with harsh cold in the northern areas. If you're in the bullseye for heavy snow, you could see significant accumulation, and then you're going to be stuck in that cold air for days. Second, the transition zone, where we could see ice and freezing rain. That's where travel becomes extremely dangerous, and power outages become a real possibility. Third, strong winds and low visibility. Even if snow totals are moderate, if the wind is howling, it's going to feel like a blizzard. And fourth, the longer-term pattern. This cold air is sticking around, and there's potential for follow-up systems. So this isn't a situation where we deal with one event and then move on. This is the start of a more active, colder pattern. The bottom line is this: we're in a dynamic atmospheric phase right now. The setup is complex. The potential for significant impacts is real, and small changes in the system's track can lead to big differences in what individual locations experience. If you're in an area that could be affected, now is the time to prepare. Make sure you have supplies, check your heating system, have a plan for if the power goes out, and stay tuned to updates, because as this system gets closer, the forecast is going to come into better focus. This is an evolving situation, and it deserves your attention.